What's up, guys? My name is Daniel, and we're going to do a practice test for the AP exam for 2020 for AP Calculus AB. As you guys probably already know, it's a take-home exam this year, and you're going to be allowed to use notes and online resources such as an online calculator. We're going to use ClassCalc here. It can be easily accessed, just classcalc.com/scientific. I'll put the link in the description. The reason we're using this calculator is because it's got good calculus features. It's pretty easy to use, pretty dynamic. So feel free to follow along with this calculator or with another calculator if you'd like. It doesn't matter too much as long as you know how to use the calculator that you have on hand. So we're going to be hand picking some problems from this test and that. All right, guys. So we're going to start. First practice problem is going to be question 2 from the 2019 exam. Which gives us some times and the corresponding velocities here of some particle moving along the x-axis, and then tells us, the particle is at the origin at time t equals 0, which you can see from here. And then part A asks us, justify why there must be at least one time t on the interval 0.3 to 2.8, such that the acceleration, which is v prime t of the particle, equals 0. And anytime we do that, anytime we give like some sort of continuum, right? Like between here and there, some sort of range, and then we say, the derivative at some point must be this. At least one of the tools in your arsenal you should be thinking about is the mean value theorem. And again, so for the mean value theorem, I'm actually going to get, I got a little animation or a little graphic. Whoops. This was made by the organic chemistry tutor, so shouts out to him. Basically explains that, hey, if you have an interval, that was a word I was looking for before. If you have an interval that's continuous and differentiable, then you have a point on the interval such that, f prime of that point equals the slope or the tangent line of the interval. If you look at this graphic here, it's basically saying that, at some point, if I have this interval a to b, at some point in the interval, the tangent line is going to be the same as the secant line. Pretty cool stuff. So here the first, we got to first of all explicitly state that the interval is differentiable and it is continuous, and that is stated. Move this out of the way real quick. That is stated very clearly in the problem. Get out of here. Whatever. We'll just do that. We'll shrink it. It's not moving. Yeah, so we could say that it's differentiable because they say it is differentiable, right? And therefore, it must also be continuous, right? So the only thing left for us to do is to apply it. And as we saw in the graphic earlier, right, that's going to be, we're just going to take basically the slope from between these 2 points. And, the way we want to think about it is, well, they're asking us to say that the acceleration equals 0. So at what 2 points can we pick here such that the acceleration will give us 0, and you can tell very clearly that that's going to be these 255s because those are going to cancel out, right? So so f prime of c, right, will be 0 on this interval, and that's going to be we could do vp1 t minus vp2 t over 2.8 minus 0.3. That's just going to be 55 minus 55 over 2.8 minus 0.3. And we've pretty much proven the point, right? That you're going to have some point f prime of c on that interval, or some point on that interval c, where the derivative of that at that point is going to equal this secant line right here. So in the second part here, they're asking us to use the trapezoidal sum to find the area or take the integral from 0 to 2.8. And these are the 3 subintervals. And for those who might not remember, right, you've got any function, and then you want to take, you want to get the area under the curve. One way to approximate it is to basically chop it up into fine little trapezoids. And so, that might be like a trapezoid number 1, and, your other trapezoid might look like this. And your next one might look like that. And so that kind of finely approximated. So as far as we're concerned, right, we're gonna have 2 heights, and that's going to correspond to the VPT of each of each interval, and then you're also going to have so those are going to be your two bases in the trapezoidal formula, which is base 1 plus base 2 over 2 times height. And then the height is going to be the length of the interval. So for example, for this interval, that would be 1.7 minus 0.3. So we're going to go ahead and write that out real quick, and I'm just going to speed this part up so you don't have to watch me write. Actually, I just went ahead and copied and pasted it from the answer guide because I don't want to, I don't know, there's no reason for me to write it all out. But you know, here we are. So we have each of the sort of, I guess you can consider this the height, right? The height of each trapezoid, and that's just going to be, you know, 0.3 and then 1.4 to get from 0.3 to 1.7, and then 1.1 to get from 1.7 to 2.8, right? And then we have the different bases here, right? So the first trapezoid, right, this is going to be the height 1 is going to be the first base, and then the height 2 is going to be the second base, and VP of 0 is that height 1, VP of 0.3 is that height 2, and then so on and so forth. And then from there we get to, and so we can go ahead and quickly plug that into our calculator. We get our answer of 40.75. All right, part C tells us that a second particle also moves along the x-axis on the interval of 0 to 4, given by some function right over here. And it tells us find the interval, right, during which the speed is at least, or the velocity is at least 60 meters per hour. And then it says find the distance traveled by the particle over that velocity, over the interval which it is traveling 60 meters per hour in. So the first thing we do is just set this to equal 60, right? So 60 equals 45 root t cosine of 0.063 t squared. And there are, I'm sure, plenty of ways to do this. The way we'll do it is we'll simply plug it into our graphing calculator and then look for the roots, right? Because we could just, so actually first thing we could do is move the 60 over here, so minus 60, and that equals 0 now. And we can now just look for the roots and make our life easy. So we'll just go to the graphing calculator, clicking over here, go to graphing. I'll go ahead and speed this part up. So real quick, on the interval given, I see that the time at which the velocity is going to be over 60, as you can see, is going to be between this point of interest and that, between this neuron, between 1.866 and 3.519. So that's what we're going to write down here, right? So that's going to be our time. Write it like this. I'll include that. And then the second part is to find the distance traveled by the particle during that interval. So we're basically, I'm going to zoom in here so we have more space, right? We're basically going to take the integral from 1.866 to 3.159 of our velocity to get the distance traveled during that time, right? We'll just do it over here where we have some space. So to make our lives easy, we're just going to go ahead and plug this into the calculator. We don't need to solve it directly. So to get this wrapped in integral, just open the parentheses. You can see the little ghost parentheses already closes it for you. So you just type in I and t, and it'll take the integral of the whole function. And we're taking it on the interval from 1.866 to 3.519. There we go. Oh, gotta get rid of that. Minus 60 here. My bad. There we go. 106.109, which is the answer. So part D basically tells us that particle Q is at position x equals 90 at time t equals 0, and then they say, you know, use the information from part B, which is the distance traveled by particle P after 2.8 seconds to see how far P and Q are away from each other. So again, we know, we know P is going to be at 40.75, right? And now we got to figure out where Q is going to be. And that's going to be its initial distance, negative 90, plus the integral from 0 to 2.8 plus the integral from 0 to 2.8 of this function, right? Q of t, sorry, V Q of t. So we can go ahead and plug that in. We already have the information all loaded up in here, so we can just go 0, 2.8, and that's going to give us 135.938, let's call it. It's going to be negative 90. Well, actually, let's go ahead and subtract 90 from that. So negative 90 plus 135.938. That's going to give us 45.938. Now we're finding a different distance from 40.75, so we can go ahead and subtract 40.75 over here. That'll give us 5.188, right? So, P minus Q, or Q minus P, right? We're taking the absolute value. So, equals 5.188. That's going to be our answer. Wow, cover the answer, but okay. All right, so we're going to now tackle question 3 of the 2019 practice exam. This is actually a pretty good one to go over. So they give us this function f and define it as continuous over the interval of -6 to 5. That's really important because they're just showing us -2 to 5, so it's very important to recognize that. The figure above shows a portion, right? The portion of the graph of f, consisting of 2 line segments and a quarter circle. So that's important. They indicate that this is a quarter circle right here. And that circle is centered at 5, 3. So we can maybe make that center over there just so we know for reference. So that's basically a quarter wedge. It is known that the point 3 minus root 5 is on the graph of f. So that's going to be this point right here, right? Where x is 3 and y is 3 minus root 5. I guess that means that the height of this is root 5. All right, so part A asks us if the integral of -6 to 5, so that means the entire graph from, let's just draw our imaginary line here and say it goes all the way to -6, right? We don't know what this graph looks like, but they're saying if that integral from here to here, -6 to 5, is 7, find the value of -6 to -2s, right? Find the imaginary integral here, right? Well, I shouldn't use imaginary since that means something else in math. And then show your answer. So basically, where we're going to find the integral from -6 to -2 is to take the entire integral, which they give us as 7, and then subtract this part, the portion they're actually showing us. And so we have to find the integral of this graph, right? So that's going to be, this triangle, this tiny triangle, this tiny triangle, this tiny triangle, this larger triangle, and then the area under the circle. So let's go ahead and section that out just so it's easy for us to see. Right? So got that triangle here. I'll cut it off over there. Got this triangle here. We got this triangle here. Right? And we got this big triangle here. And then we have the area under the circle. So we just kind of do this. And so just to kind of write out the work to show the work, we'll say, it's going to be the integral of -6 to -5, f of x dx. Let's zoom in so it's smaller. Minus the integral of -2 to 5. F of x dx is going to be our answer, right? And so this is going to be 7 minus, and then we got to solve this, right? So let's actually go ahead and number these. We got 1, 2, 3 over here, 4, and 5 pieces, right? So piece number 1 is just going to be base times height is 1 times 1 over 2, so half. And then piece number 2 is also going to be a half, so it's going to be minus. Piece number 3 is going to be a quarter, and you can see because it goes either, you could either see that basically drawing the triangle again would give us half the square, right? So you know it's going to be a quarter of the square. So that's going to be 1/4, or you can see that the base here is a half. So it's going to be a half times 1 over 2, which is going to be a fourth, so minus a fourth. And then this triangle is going to be 1.5 times 3, right? Which is going to be 4.5 over 2, or 9 over 4, so plus 9 over 4. Right, and then this circle here is going to be, well, it's got a radius of 3, we know that. So that's going to be a 2 pi r, pi r squared, which is going to be 9 pi, right? But it's only a fourth of that, right? So it's 9 pi over 4 is this circle. Let me just draw that in here, 9 pi over 4, right? But it's actually going to be this area under the circle, right, that I'm shading. And so that's going to be, you know, this imaginary, well, I should use that again, but this square over here, right, which is going to, it's a 3 by 3 square, so it's going to be 9 minus 9 pi over 4, right? So plus 9 minus 9 pi over 4. All right, now let's go plug it into the calculator. That gives us 3.069, which will be the right answer. Right? 3.069 is the right answer. All right, so for part 2, they ask us to integrate from 3 to 5, take the integral of 2 f prime of x plus 4. Right, so we can go ahead and start solving this. And so we can split that up into 2 pieces, right? 2 f prime of x and then 4. And for the 2, we can factor that out. So that would be 2 times the integral from 3 to 5 of f prime of x plus the integral of 3 to 5 of 4, right? And so for this, we're going to get 2 times the integral of f prime of x is going to be f of x, right? The integral of the derivative of a function is just the function. So it's going to be f of 5 minus f of 3. And then that's going to be plus the integral of 4 is going to be 4x, so it's going to be 4 times 5 minus 4 times 3. And so that's going to give us, let's do 2 times f of 5 minus f of 3. So f of 5 is going to be this 0 here. And f of 3 is actually going to give this point they gave us before. So f of 5 is going to be 0 minus 3 minus root 5. Watch your minuses over there. Be sure to use parentheses. And then plus 20 minus 12, right, which is going to be plus 8. And so that's going to be negative 6 plus 2 root 5 plus 8, which is going to give us 2 plus 2. Let's get rid of that over there. 2 plus 2 root 5. And if we want, we can plug that into our calculator. Get an answer of 6.472. There we go. And a quick note, I usually, I think for problems like, sorry about that. For problems like this, I think you might be fine not calculating it, but it's always good to do so just in case. So in part C, we're given that the function g, given by g of x equals the integral from -2 to x of f of t dt. And then it tells us to find the maximum value of g on the interval of -2 to 5, right? So basically, they're telling us that g is the integral of this function f, and they're telling us to find the maximum value. And so theoretically, that could occur at the start point if the entire function f was on the graph, or at one of the critical points, right? So that's going to be -1, half, and at 5, right? At all the zeros. So we've already solved this in part A, right, basically. So it's pretty easy to speed through. The integral at -2 is going to be 0. For x is -2 is going to be 0. If x is -1, right, the integral is just going to be a half. If the integrals, if x is equal to a half, it's going to be 1/2 minus 1/2, and then minus 1/4, so it's just going to be -1/4. And so looking at x equals 5, that's going to be the integral of the entire graph, which was at least part of the answer to part A, which was 11 minus 9 pi over 4. And you can just tell graphically that that's going to be greater than, at least greater than a half, right? And we can check that against the calculator just in case. Which gives us 3.93, which is going to be greater than half. So it's going to be, at x equals 5, it's going to be the global maxima, and it's going to be this. Now in the final part, they ask us to solve for this limit. And so basically, as far as this problem is concerned, we can plug in 1, right? So it's going to be 10 to the 1 minus 3 times f prime of 1. So it's going to be the slope of f of x at 1 over f of 1 minus arctan of 1. And so 10 to the 1 is going to be 10. The slope at f of 1, right? So we go up here and we see that's going to be right over here. And the slope over here, the rise over run is 4 and the run is 2. So it's going to be 2, right? The slope is going to be 2. So the derivative at x equals 1 is going to be 2. So it's going to be 3 times 2 over f of 1. We go back here and we see f of 1 is going to be 1. 1 minus arctan of 1. And now we can go ahead and plug this into our calculator. So that's going to be 10 minus 6 over 1 minus arctan of 1. And we want to make sure we're in radian, which we are right now. So that's going to be 18.639. Which is the correct answer. All right, now for our last problem, we'll do question 2 from the 2016 exam. I thought this was a nice one to go over. So the question asks, for t greater than or equal to 0, particle moves along the x-axis. The velocity of the particle is given by this function. And then the particle is at position x equals 2 at time t equals 4. So at time t equals 4, it asks us, is the particle speeding up or slowing down? And so what we'll want to do here is get the velocity and the acceleration at t equals 4. That'll tell us exactly what we need to know. Now remember, it's not just enough to get the acceleration here, because if you had, for example, a negative acceleration and a negative velocity, technically the object is speeding up in the negative direction, right? So you need both the acceleration and the velocity, and then basically to compare their signs. So we're going to have to calculate v of 4 for the velocity at 4. I'll write it down right here. We need to calculate v of 4, and we need to calculate v prime of 4, right, which would be the acceleration at t equals 4. So we're going to go ahead and use our calculator for this. So the function is 1 plus 2 sine of t squared over 2. And to solve it at x equals 4, we'll go ahead and actually declare that function with f of x and then just have f of 4 to get velocity of 2.978. And then to take the derivative, we could actually do d by dx of f of x, and then denote that we want to solve that at 4. And you can see it even gives us a slope, which is nice. And so it's going to be a positive velocity and negative acceleration, so we know that that means it's slowing down. And obviously we want to write that down, right? So 2.98 for velocity. And then for acceleration, it's negative 1.16. So it's going to be slowing down. I'll write the whole thing, save you guys time. All right, now in the next part it says, find all the times t where the interval, on the interval, sorry, t is between 0 to 3, where the particle changes direction. All right, so a change in direction will just be defined as the velocity going from negative to positive or from positive to negative. And it's just on an interval of 0 to 3, so we can go back to our calculator and we can check out our function, right? This is our function again, and on the interval we see, on the interval from 0 to 3, we being right around, well, right around here actually. The only 0 we have is right here, so it only changes direction once at t equals 2.7. And again, just to review, this is the graph of velocity that they're giving us, right? And the velocity going from positive to negative, right? So at one point it was going in the positive direction, the next point is going in the negative direction, so you know that's one change of a direction. Part C asks us to find the position of the particle at time t equals 0. So to do this, we're going to have to take basically the only information they give us for some sort of starting direction, which is at x equals, the particles at x equals 2 during time equals t equals 4. And then we're going to have to basically use an integral on the velocity to subtract distance away from that to see where we are at time t equals 0. So that's going to be the position at time t equals 4, which is going to be 2, plus the integral, right? And we're taking a negative integral, right? So it's going to be from 4 to 0, right? We're going from the velocity 0 to the velocity being 4 to the velocity being 0 of v of t, which will give us the distance traveled over that interval. And so we have to take the integral from 4 to 0 of the velocity. We can go down here, integral f of x, 0 and 4, and that's going to give us negative 5.815, which is plus 5.815. Which is going to give us negative, oh, sorry, that's actually supposed to be a negative. Negative over there. Negative 5.815, which will give us negative 3.815. And now the last part asks us to find the total distance that the particle travels from time t equals 0 to t equals 3. This is a very easy one to lose some points on, because if you just took the integral, well, let's actually look at the graph, right? And let's go ahead and take the integral on the graph. And this is, again, I always say that it's nice to have a graphing calculator in front of you because it's really good to get a graphical representation. Let's take the integral from 0 to 3, right? So 0 to 3, and then let's get rid of these two out of our way. So this is giving us basically, this numerical answer is giving us the position, right? Which is what the integral of the velocity is. But to get the total distance traveled, we'd actually have to add this part here instead of subtracting it because it is technically distance traveled. And so the way to do that would be to either break the integral up into two parts and then add this one to this, or you can actually just take the integral of the absolute value. And so you can type in ABS for absolute value and it'll automatically wrap it. And that gives us 5.301, which is going to be the distance. So really easy to lose some points over there. And I would say in general, whenever you have any of those physics terms where your teacher kind of explicitly teaches you the difference, like, oh, you know, speed versus velocity, position versus distance, it's really important to pay attention on any AP test when they're using that terminology, and to be very explicit with what you read as the answer. I guess we should write it out here. Integral from 0 to 3 of v of t absolute value dt equals. All right, guys, and that wraps up our AP Calculus AB practice test for 2020. If you have any questions, as always, please feel free to leave it below in the comments. And again, I am new to this, so if you have any feedback or any way I can help you guys succeed on the AP test this year, please let me know. And I will leave links to ClassCalc as well as the practice test in the description below. Until next time.